All right, so this is going to be a really important lesson today, guys. This is something that we're going to be referring to a lot. You're going to see this on your keystone. It's basically called FOIL, and anybody who's taken Algebra 1 before can tell you about FOIL. You're going to see this a lot in Algebra 2. Okay, now this is kind of like a subset of what we talked about yesterday, just like a smaller version of what we talked about yesterday with multiplying polynomials. This is when you multiply binomials. Now, that means that we're taking a binomial and multiplying it by a binomial like this. The thing is that it can be kind of difficult to make sure we actually distribute correctly and multiply everything. Okay, if we try to do it just by hand, we can make a lot of mistakes. So one method that people have come up with is called the grid, where we kind of line up each of the pieces of our binomials into this grid-like shape here, and then multiply each of the things that match up in the grid to get what are resulting, when we multiply these binomials together, what will result. Okay? So, if I line them up in the grid, I would do 3k times k and get 3k squared. The next part, I would do 2 times k and get 2k. Next one, 3k times negative 4 would be negative 12k. And then the last part of my grid, I'm starting to write x instead of k. Last part of my grid, 2 times negative 4 will give me negative 8. Now, this would be the resulting polynomial I'd end up with. So I have 3k squared plus 2k minus 12k minus 8. But you might be saying, hold on, Mr. Guy, there's something going on here. Do you guys notice what's going on? You should see that you have like terms. A k here and a k here. Yes, you do. That means we can combine those together and take this and actually turn it into a trinomial because these two terms can be added together. In fact, in this case, it's actually subtracted. So we're going to have 3k squared minus 10k, because 2 minus 12 would be negative 10, minus 8. And that would be our final answer when we multiply these together. Okay, multiply these two binomials together, we end up with this. That's because we're trying to distribute and make sure everything multiplies by everything else. That's our goal when we're doing this, okay? You guys go ahead. I have a little table right here. I'll even set it up for you. Go ahead and try to multiply these using this table method and see how you do. Once again, pause the video, and then after you're finished, come back and check and see how you did on this. All right, if you restarted the video, you should see my answer now. If you look in the chart, 4b times b is 4b squared. 4b times negative 7 is negative 28b. Negative 3 times b is negative 3b. And then negative 3 times negative 7 is 21. Over here, I have the answer written out. But, of course, these middle two terms will combine together. They both have a single b with them. When I combine them together, I get this final answer, our final trinomial, 4b squared minus 31b plus 21. That would be the product of these two binomials when I multiply them together. Now, that table method that we just talked about is all great. It works, and it'll work for you. And if you want to draw a table every time, you can go ahead and do that. However, as we've learned through this course, mathematicians are lazy, and they like to come up with other ways to do things that are faster. Okay, we don't want to have to draw a grid every single time we go to multiply these binomials. And that's where FOIL comes in. Now, this is not the same as the tinfoil you use to wrap your sandwich in. Okay, this has to do with just a way to remember what FOIL stands for. Okay, it's going to it's going to help you remember. That's the word I'm looking for. How to use the distributive property when you're multiplying these binomials. The first letters are going to remind you of what you need to multiply. FOIL stands for first, outside, inside, and last. First, outside, inside, last. That is FOIL. Now, FOIL is really important because it's going to basically cut down a lot of time on multiplying these binomials. When I go to multiply them and distribute them, I'm going to make sure I remember to distribute everything by multiplying the first two terms together. In this case, the x and the 3x. I'm also going to do the outer terms, x times 1. That's the O. I'm then going to do the inner terms. That's the I. And then last but not least, I will do the last terms that show up. That's the L. This is FOIL. First, outer, inner, last. And all that we're going to do is we're going to basically follow these arrows, the first, the outer, the inner, the last, and multiply them, and it's going to give us the same answer we got before. So for first, x times 3x is going to give me 3x squared. I've now done my first. I can go ahead and cross that off. Next one is the outer. That's x times 1. It's going to give me plus x. Remember, you could have a 1x if you wanted to. You don't need that there. That's the outer. Next is the inner. Negative 5 times 3 is going to give me minus 15x. And then last but not least, we'll do negative 5 times 1 and get minus 5. Once again, you should notice that these middle two terms can combine together. You're going to notice a pattern with that. Almost every time you FOIL, these middle two terms will be able to combine. That's not always a fact, but it does happen a lot. So it's kind of nice that they always end up right next to each other. So we can combine these like terms together and end up with 3x squared minus 14x minus 5. And that, ladies and gentlemen, is FOIL. Okay, if you ask anybody who's in Algebra 2 right now, they'll be able to tell you like FOIL like the back of their hand. When you guys take Algebra 2 next year, you use FOIL all the time. For the rest of the year at Algebra 1, we don't have a lot of time left, but we'll be talking about FOIL a lot. FOIL is very important. Okay, being able to FOIL is going to be essential. It's going to be a couple questions on your Keystone exam being able to do this. And it's really not that bad. It's just an acronym to help us remember to multiply binomials correctly. First, outer, inner, last. Let's look at one more example together to kind of give us a better idea about what's going on. Again, if I'm using FOIL, I'm going to do my first, my outer, my inner, and my last. Now you'll notice I'm not writing the letters this time. When you go to do FOIL, you do not need to write the letters every time. You do, however, need to write the arrows to help you remember what you're multiplying together. Okay, so write these arrows and then do first, outer, inner, last. You do not have to write the FOIL. First is going to be 3a times 2a. That's going to be 6a squared. Next, we're going to do the outer. That's 3a times negative 8. That's going to be negative 24a. Next, we're going to do the inner. That's going to be 2 times 2a. That's going to be plus 4a. Then last but not least, we're going to do the last. 2 times negative 8 is going to be minus 16. Once again, in the middle, I have two terms that will combine together using our like terms. I'll go ahead and combine those together and end up with 6a squared minus 20a minus 16. And there is my final answer. Okay, that is using FOIL to find the product of binomials. First, outer, inner, last. Multiply the first terms, the outer terms, the inner terms, and then the last terms. And that makes sure that is what makes sure that we distribute everything correctly when we're multiplying two binomials together. All right, this is going to be where you guys are going to try one. Go ahead and write this down on your paper or look at this one and then go ahead and multiply these together. Once again, once you're finished, you can then unpause the video, check to see what I got, and check it with what you did. All right, hopefully you attempted this one, and now you're checking your work with what I did. If you go ahead and take a look here, you should have ended up with 21a squared minus 34a plus 8. If you did not get that, the first thing you probably want to check is make sure you FOILed correctly. You did first, outer, inner, last. If you did that correctly, then check your signs. Okay, make sure you have the correct signage everywhere so that when you combine everything together, it gives you the correct numbers. Okay. For the first multiply, you should have gotten 21a squared. For the outer, you should have gotten negative 28a. For the inner, negative 6a. And then for the last, positive 8. Two wrongs make a right in math class, okay? And that's going to be a correct answer for this FOIL problem. Again, FOIL, first, outer, inner, last. I'm going to keep saying it until you dream it in your sleep. First, outer, inner, last. Okay? Now, we can use this to help us simplify polynomials. Sometimes they're going to give us a giant, long, gross thing and say, hey, can you fully simplify this? Can you write it in standard form where it doesn't have all these parentheses and doesn't look so gross? We can do that now because not only do we know how to distribute, we also know how to FOIL. So what we're going to go ahead and do is we're just going to go ahead and distribute. And part of distributing is doing FOIL. First, outer, inner, last. When I distribute over here, you're going to get 3w squared minus 5w. Cool, cool, cool. Over here, I go ahead and I FOIL. I'm going to get w, times 2w is 2w squared. W times 4 is 4w. Negative 2 times 2w will be minus 4w. And then negative 2 times 4 is minus 8. I'm now going to go and try to look for some like terms that I can combine together. Right here off the bat, I see a w squared and a w squared. So positive 3w squared and positive 2w squared will be 5w squared. I see negative 5w, positive 4w, and negative 4w. Well, look at that. These two will cancel out and make 0. So all I'm going to be left over with is negative 5w. And then over here, this minus 8, it's all alone, has no friends. It stays the same. And there's going to be your solution. And when I go ahead and I simplify this into a nice, neat package, there's the polynomial that it represents. Okay, a lot simpler. This is what we call standard form, right? We have each term. They're in order. We have the squared, then the ones, and then the constants over here, the zeros, okay? Everybody okay with that? I hope so. Now, we can kind of do this to solve some geometry problems as well. When we know how to FOIL, these sorts of problems that look really, really complicated actually really are a lot simpler. It says find the polynomial that represents the area of the shaded region. Now, hopefully you remember from last year's geometry that the area of a rectangle is length times width. That is all we're doing here. We're going to take the length times width of this purple rectangle that I'm highlighting right now. And then what we're going to do is we are going to use that to figure out and subtract away this one in here, this kind of white rectangle in here. If we take the purple and we subtract the white, that's going to leave us with the area of the whole rectangle that we want. So in order to do that, I have to figure out the area of the rectangle on the outside. So the area outside. And then I also need to figure out the area inside. Area inside. What I want you guys to do is I want you to go ahead and give this one a try. Okay, try using our FOIL method, our multiplying, to find what the polynomial would be, the area of the outside. Then find the polynomial that represents the area of the inside. And then, after you do that, go ahead and subtract them and see if you can combine like terms and come up with the polynomial that represents the area of the purple part, the shaded region. Go ahead and try that for me. All right, so if you go ahead and take a look, first part, the area of the outside, length times width. I had to use FOIL in order to figure that out. I got 15x squared plus 29x plus 8. For the area of the inside, I had to do distributing x times each of these. I got x squared plus 2x. And then I went ahead and subtracted them, and this is what I ended up with over here after subtraction. Again, if you're confused about how I got this, make sure you distributed this negative 3. You got to subtract both of these things. So I get 14x squared plus 27x plus 8. That'd be the area of that shaded region. This right here is an example of a question they might include on the Keystone exam where they're really testing if you know how to FOIL. It looks a lot more complicated than really what it is. If they just gave you the calculations, you'd be able to do them, but they want to see if you're able to set them up. You have to think back to last year when you took geometry and think about some of these things that you already know, right? You know how to find area of a rectangle, length times width. So do not shut down when you see a problem like this, because if you just kind of take it baby steps, all right, well, let me find length times width. Oh, yeah, I know how to FOIL. Let me try length times width the inner thing. Oh, yeah, I know how to FOIL. Oh, in geometry, to subtract those, let me try that, and all of a sudden you have the answer, okay? That concludes our lesson on FOIL. This is a really important topic. If you were confused about how to FOIL, please go back and rewatch parts of this video. If that doesn't help you, you can always go on YouTube and look for another video to help you out. Or during a different time, not during this period, but maybe during DA or 9th period. Try to find a peer that might be able to help you, or go to another math teacher, either Mr. Elder or Mr. Stifler will be welcome to help you during 9th period if they are available. All right, that concludes this lesson. Thank you guys for watching.